Welcome. I'm Michael Krasny, and I want to welcome you to another episode of Gray Matter. That's Gray with an E, Interviews with Michael Krasny. It's a podcast which features in-depth interviews with leading newsmakers, scholars, authors, and intellectuals, and today a leading scientist. And you can find out all about us and access previous episodes of Gray Matter simply by going to Gray Matter, again, Gray with an E, .show. In this, our sixth episode, we want to welcome Andrew Fraknoi, who served for many years as chair of the Department of Astronomy at Foothill College and as executive director of the Astronomical Society of the Pacific. Andrew Fraknoi has explained astronomy with what I would describe as astute and acute and often passionate lucidity, and sometimes even in astronomy's greatest complexity, and explained it to legions of people in both radio and television and in print, including in his role as lead author of the most frequently used astronomy textbook in the United States. It's called simply Astronomy, published online by the nonprofit Open Star Project at Rice University. He's now a retired professor, and he continues to teach in ongoing education for retirees at both the Fromm Institute at the University of San Francisco and also the Osher that's Lifelong Learning Institute at San Francisco State. And as well as reinventing himself recently as a writer of science fiction. He's got a number of places that he has published his science fiction in. Time permitting, we may even talk about science fiction. But let me also add that the International Astronomical Union has honored him for his work on behalf of public education and science by naming an asteroid after him, asteroid 4859, otherwise known as asteroid Fraknoi. And welcome, Andy Fraknoi. Great to have you with us.
Oh, great to be with you.
And that, by the way, asteroid is between Mars and Jupiter. It's no threat to the Earth. We should get that out of the way right away. And so much I want to talk with you about. I mean, we've got, of course, the James Webb Space Telescope, which is on many people's minds. I want to talk about the search for extraterrestrial life. The History Channel has made it clear that it already existed in past time. They don't do much history anymore. They just do ET stuff. I want to talk about the Mars mission, black holes, dark matter, and we've got an audience ready to ask questions, and I'm really looking forward to this conversation with you. Let's start off, though, by talking about the Webb telescope. I mean, it's already kind of putting the Hubble to shame. It's amazing what we're seeing. It's really mind-blowing, and we could spend the whole hour just talking about that. I mean, just most recently, for example, measuring the most distant galaxy. But talk about, in fact, the first question that I see has come from one of our listeners in Seattle, and thank you for the question, who wanted to know what you see particularly that the Hubble telescope is making us see or allowing us to see.
Well, so the James Webb Space Telescope is really a next step in our exploration of the universe. It's much bigger of a telescope than the Hubble. The James Webb Telescope overall is about the size of a 3-story building, a mirror the size of a 3-story building. Think about that. But even more exciting, it's not a telescope designed to bring you light from space. Instead, it looks for and records infrared, which we call heat rays in everyday language. It's the radiation that things that are warm give off. If they're warm enough, but not so hot that they glow with light, then they give off infrared radiation. And there is a huge array of things out there in the universe that we can't see very well with light, but that spring into view for us when we observe them with infrared. Among these are stars just being born, baby or infant stars, even the material from which stars are born, planets orbiting other stars which are too faint to give off their own light very much. We look at distant cities of stars called galaxies, so far away that we're seeing them at the dawn of time. All of these things are better seen with infrared than with visible light. The problem is many of these things are quite faint, and you need a big mirror, a big telescope to catch enough faint light to reveal them to us. And that's what the James Webb Telescope is. It's a giant mirror in space.
It hasn't been, has it though? I'm interested in your opinion about this, oversold. I mean, we've been people have been talking about it's going to find out what happened before the Big Bang. It's going to give us a portal into cosmology that we have never imagined. I mean, these are the kinds of things that I'm reading about. Maybe tell us finally, is there a God, or is...
Well, no, those are probably not coming from scientists, but you're right. NASA, because it has had so many cost overruns on this telescope, is incredibly invested in convincing Congress that they spent their money wisely on this giant telescope. It took a lot of new technology. For example, it's a mirror made of segments, 18 different segments in hexagon shape that fit together like a puzzle. And the 18 segments together were much too big to fit into the spacecraft that delivered them to the point where they are. So once it got to this point, 1,000,000 miles from Earth, the segments had to unfold like the petals of a flower. They had to literally unfold themselves, get into position, and then align themselves with every one of the 18 segments. Each segment has to be aligned precisely with the other 17. And doing that remotely 1,000,000 miles away was an incredible technological challenge, and it worked flawlessly. So to some degree, NASA deserves to crow a little bit about the mission.
Well, this galaxy that I mentioned before, about the speed of 18 million miles per hour, and we're learning more about galaxies than we ever imagined we'd learn. We're learning about how they evolve, and it's kind of smashing former theories that existed, isn't it?
Well, not quite yet, but we're hoping it will. So let's set the scene for our listeners. The universe is organized into star systems like our sun and the planets that surround it. And then those star systems are organized into giant islands called galaxies. We live in one such galaxy called the Milky Way galaxy, and the sun is part of that. And every star we see is part of a galaxy. Despite what Texas claims, there's no such thing as a lone star. Every star is organized into these galaxies. And the remarkable thing we discovered in the last century is that these giant islands of stars, these galaxies, are actually moving away from each other. They're expanding. Every direction we look, the galaxies are moving away. We think the whole universe is stretching, is expanding. And so as we look out into space, we're looking back into time. That by itself is a when I was on your show before, this was a mind-boggling concept we talked about quite a few times, that because light is not instantaneous, it takes a while for light to reach us. So if we look at a galaxy, one of our nearest neighbor galaxies is 2 million light years away. What that means in English is the light we see tonight left that galaxy 2 million years ago. If we see a galaxy 1 billion light years away, the light we see tonight is billion-year-old light. Now, you might say, hey, I don't want old light like that. I want new light. I watch CNN. I want the latest. But because this light is older and older, as we look further out, we can reconstruct the history of the universe by looking far out. So finally, answering your question, that's what the James Webb is doing with these galaxies. It's looking so far out that we're looking further back in time than we've ever been able to do.
So we can possibly get back to the Big Bang or even before it. And I'm struck by something was UC Berkeley's John Mather, who I'm sure you know, who shared a Nobel Prize with George Smoot, was talking about how there's a lot of misconception about what the Big Bang is. It's not a firecracker, he said. In fact, it goes back to something you said a moment ago. It's about the expanding universe that we can see. And it's also something that happens everywhere as opposed to simply some place in time or some specific place in time. So we're actually going to get back to, and maybe even before the Big Bang?
No, you can't see anything from before the Big Bang because that's where space and time begin. But very close to the Big Bang is the exciting, just as you say. It's that as we look further and further back, we get back to a time when stars and galaxies were first forming from the chaos of the original soup that gave rise to the universe. It was hot, it was chaotic, it was random. That's what George Smoot and John Mather got the Nobel Prize for, is observing the sort of the echo of that great chaotic time. And then out of that chaos came gravity, pulling things together, making galaxies, making stars, making planets, eventually making Michael Krasny listeners. And so this process of forming order from the chaos, that's something that we can't see very well with present day telescopes, but we hope to see the first pieces of it with the James Webb Space Telescope.
What about these folks who are saying, I said before the Big Bang, and I realize we don't know or can't probably divine, I use that word advisedly, what was before the Big Bang. But there's a lot of talk about the Webb telescope talking about the intent of the Creator, and you can see the presence of the Creator, or the fingerprints, if, as it were, if there are hands that Creator has.
Well, this is not my department. You have to ask somebody more into religion. But what I can tell you is that if you see the universe as the handiwork of God, and people who are religious often have that sense that when we see the beauty of the night sky, these galaxies, these stars.
Excuse me, it's not only people who are religious. I mean, Einstein talked about that beauty, didn't he, as being maybe the handiwork of a
he did.
Powerful
and he
force.
himself had a religious view of his own. He had a unique kind of religious view. But yes, I think you could certainly interpret the grandeur of the cosmic scheme as something that gives you something akin to a religious feeling. And many people love astronomy because of that. So I think what we are going to see is more of the pattern of creation. We're going to see how material in the universe organized itself into the web of galaxies that we are seeing today.
When we talk about perhaps divine intent and those kinds of things, I realize we're going outside of the realm of science, and yet there are many who are saying that this beauty of the universe, this aesthetic response that people have to the universe, and how manifold things are, and how often symmetrical they seem to be, and how ordered they are, gives us a clue to something greater than ourselves, or something that we can't understand.
Well, and I mean, I think this is what I've taught, as you kindly said, I've taught astronomy for many decades and have had many students who have discovered the universe through the classes. And what they always say is exactly what you're saying now, is that studying astronomy has awakened me to a much larger pattern, much larger grandeur than my everyday life, that we can see the scheme of how the universe evolves. For example, one nice illustration of what you're saying, Michael, is that when the universe began, we have lots of evidence that it began with the simplest elements, hydrogen and helium for the most part. Now, you cannot build a podcast listener out of just hydrogen and helium. You need a lot more interesting atoms, including carbon and calcium and all the things we're made of to make humans. So one of the great questions of science has always been, how did the simplicity of the early days turn into the complexity of today? And we now know the answer. New elements are forged inside stars. It is in the stars that it's hot enough for nature to bring together, to fuse together simple elements into more complex ones. Some stars explode at the end of their lives, releasing these new elements. And our sun, our Earth, and we humans are the products of 3 previous generations, at least, of star birth and star death. So 3 generations of stars had to die before we came about. And so we are actually made of their products, of their carbon, their oxygen, their iron. And our bodies, in that sense, are made of star stuff, as Carl Sagan used to say. We are made of what stars have produced. And that gives a really nice sense of connection between us and what happens in the universe.
You were talking about looking at the stars, gazing at the stars at night and all of that. It's harder with electric lights now. I mean, it makes it very difficult, doesn't it?
Oh, yes. This is a topic which is really a painful one for astronomers, because the what we call light pollution, the fact that for most places now on Earth, the human lights are so strong that you can't see much of the night sky. Very few people have seen the Milky Way galaxy splashed across the sky because it's so bright in so many places. To make things worse, there is the new problem of the constellation satellites. SpaceX and a number of other companies are launching low Earth orbit satellites to bring Wi-Fi to many parts of the world, which many people consider a good thing. But these satellites were produced in such a way that they reflect light. And that reflected light looks like a streak of light across the sky. And they're planning thousands of these reflective satellites in low Earth orbit, which means just about every astronomical photograph will have a streak in it from one of these reflective satellites. So we are working desperately with SpaceX and other companies to try to get them to paint these things black and to change the way they reflect light, so we don't get this incredible extra problem in seeing the night sky, which is these little streaks of light that will be constantly across the night sky.
We've got some questions that I want to go to, and I also want to talk to you about SETI. You've been very involved in that. I should have mentioned in the biography, SETI is the acronym for the Search for Extraterrestrial Intelligence, and we'll find out if there is indeed something out there. Andrew has called this a Star Trek moment. We'll find out what he means by that. And Chad Lafarge, actually joining us from Columbia, Missouri, one of the members of our team, wants to know, without a James Webb budget, how can I help my kids to fall in love with space?
Ah, that's a great question. So, there are lots of great books out there for kids. Go to your library and check out some of the astronomy books for kids. I myself, years ago, wrote something for Disney called The Wonderful World of Space, that the Disney publishing company published, with not only wonderful pictures, but also really bad jokes that the Disney characters make about astronomy. But yeah, that's one way. Another thing is to find you the local science museum or science center in your community. Many of them have great programs for kids, and getting them excited about science is a wonderful thing you can do for them.
And Hasmukh Gujar from Cape Town wants to know, where does the SKA Radio Observatory fit in our understanding of galaxies?
Oh my goodness, you know a lot. SKA stands for Square Kilometer Array. What we want to do, this is not yet happening, but the prototype has been built. We want to build in the southern hemisphere a whole bunch of radio dishes that cover an entire square kilometer. We'll just fill out a square kilometer full of dishes. And what these dishes will do will be to listen in, not on the visible light from the universe, not on the infrared that we talked about a minute ago, but on radio waves. Turns out the universe also gives off radio waves. And those radio waves tell us about, again, a whole different set of things going on in the universe. Galaxies that collide, for example, will give off radio waves. Stars that explode, their remnants give off radio waves. Cold gas ready to be turned into stars gives off radio waves. So we're using those radio waves to complement what we see with light, what we see with infrared, to get an even more complete picture of what's happening in the universe. So yeah, this maybe in the next decade or so, we'll get that square kilometer array.
Let me thank these folks who are joining us with questions here. There are a lot of them. I'll try to get to a few more. John Snyder in Reno, Nevada says, what is an astronomy topic that children grasp easily but adults have difficulty understanding?
Now that's a question I've never been asked before. What an interesting question. Something that children grasp easily, but adults have trouble with. I think to some degree, I think it's the brilliance of the sun. It's the idea that the sun is the source of light and energy for human civilization. It's something that kind of comes naturally to kids because they so enjoy the sun. But thinking about the sun is more complex for adults. I think for many of them, the sun has become more abstract than a facet of everyday experience. But one of the things we understand now is that without the sun, life on Earth could not have started. Without the sun's energy, making the whole process of life beginning and then life evolving possible, we would not have evolved on the surface of this world. So we ask ourselves, around other suns, around other stars, how much light and heat will be required for a planet to develop life? What is the requirement, the minimum daily dose, if you will, of light and energy to make life possible? And that's a topic of great debate right now among astronomers. How faint a star is a suitable home for life?
Well, since you brought up suitable homes for life, we can talk about SETI now, and then I'll get to more questions, because I've been fascinated with this since I was a child. I remember being very excited seeing advertisements for stamps that are supposedly from the civilizations on Neptune and Pluto. And I thought, boy, add this to my stamp collection as a young boy would be fantastic, because I thought, man, there must be life out there. I mean, I was probably all about 6 or 7 years old at the most. Astrobiology, I guess people still call it exobiology, has been one of the most fascinating areas of study to many of us, and I know it's been very important to you. And NASA announced there are 5,000 planets that are essentially could sustain life probably, or have suns that are very much like ours that are orbiting suns. 1994, what was it? NASA thought there were none like that. So, and we've got Jupiter with all its water. We've got all kinds of possibilities there. I want to talk to you a little bit also with Professor Loeb's idea of trash coming from the chair of the astronomy department at Harvard, who claims that we had trash come to us from another civilization in outer space, or at least the plausibility of that. But we still don't have an answer to whether we're alone or not. Right. I mean, that's right. Bottom line, isn't it?
So this is, of course, for many people like you, and for me, certainly one of the most fascinating questions is, if life arose on Earth, could it have arisen elsewhere and evolved to become intelligent? Because as much as it would be really exciting to find, amoebas on one of the moons of Jupiter, which, as you say, has water under the surface ice, what we're really looking for are beings with which we could in some way converse and have good exchanges like we do on gray matter. Wouldn't it be great for you to interview someone from another civilization? So it's intelligent life that we're looking for, and that's SETI, the search for extraterrestrial intelligence. The first experiment in that area was performed in 1960 by Frank Drake. We tried to tune in possible radio messages from other civilizations. Not that they would be directed at us necessarily, but that they might be communicating with an outpost of theirs or just sending a beacon out, and we could overhear it. And it's, of course, incredibly complicated to know what channel they might be sending on, which star they might be around, how they code their messages. So it was just a little bit of child's play at the beginning. But now a billionaire in Silicon Valley has given Berkeley $100 million to really make a much more sophisticated search for alien messages than we've ever been able to do. And the Berkeley people, together with the SETI Institute that you mentioned, I've been involved with since the beginning, and a number of other institutions, are now taking this money and really beginning to do the most thorough search of possible radio messages from the stars ever undertaken.
Is it foolish of me, though, to think, as I have since I was a child, that we keep hearing life as we know it, with carbon and all of the things we associate with this planet, that there could be life out there that we don't know, that we have not even a glimmer of?
Absolutely. So we are based on carbon, and it turns out carbon is a really good element for making life. It's very friendly. It makes a lot of bonds. We used to call it the Bill Clinton of elements because it never liked to be alone. It always likes to be in a crowd with other elements and make lots of complicated bonds. Other elements could also be the basis of life, but carbon turns out by far to be the easiest. So there's some reason to think that carbon will be popular as the chemical basis of life. But you're absolutely right. there could be life completely different, based maybe on electrical connections rather than chemical connections. There could be perhaps life in great plasmas out there. There could be life which is based on different rules that we haven't yet discovered even. So we're very modest about our expectations. We look for life as we know it because we know our knowledge is so limited. And science is all about finding out new things. We'd love to learn about life as we don't know it, but let's not let that stop us for looking for life as we do know it and looking for life on planets, which is where we evolved. So that's what we're doing. We're, as you said, in 1994, scientists did not know a single planet for sure around other stars. We thought there must be, but we couldn't find them. Planets are faint, stars are bright. It's very hard to find planets. And since 1995, with efforts in several countries, including at your old institution, San Francisco State University was one of the pioneers in finding planets. Jeff Marcy at the San Francisco State was one of the first people to find planets around other stars. And now we have more than 5,000 planets orbiting other stars. And we think that's still just the tip of the cosmic iceberg. Some people are saying that there could be 100 billion planets in our Milky Way galaxy alone. 100 billion planets. When you think about that number, it makes you realize that even if only a tiny fraction of those evolve intelligent creatures, that's still a lot of opportunities for intelligent creatures to evolve. And so we'd love to communicate with them. We'd love to overhear messages they might be sending. We'd love to find what we call techno signatures, signatures of alien technology. And this $100 million has made that project a lot more interesting and possible.
Well, the 100 billion planets you speak of, you take those and you multiply them by probably hundreds of billions of galaxies. We don't even know how many galaxies are out there, and all the alternative universes that at least we're being told about with a lot of modern physics, and universes which may be in fact like ours or unlike ours, something we can't even conceive of. I mean, the mind can't get around all that. So you say it's a Star Trek moment. What do you mean?
Well, in Star Trek, every week they went to a different star, and there was always a planet around that star with interesting creatures or something they had to deal with for an episode. And I always thought to myself, it's so great to imagine a universe in which every week you found another intelligent life form. I wish the universe were like that. And although we haven't found intelligent life forms, just the number of planets out there, it seems to make it more likely that if we had an Enterprise which could travel quickly among the stars, they'd have an interesting journey, and maybe every stop they'd find something new and different.
There's a recent discovery of the fastest moving star. And we learn a lot by studying these stars about the orbits that we study around the stars. We learn a lot about black holes. We learn a lot about dark matter. We're learning more and more about dark matter, which is something I'd like to maybe have us educated a little on from your expertise. You can't detect it, but we know it has effects, so it's there, even though it can't be detected, right?
So you've asked three questions here. Can I take them in order?
Absolutely.
First thing
Parse
is
them.
First thing is the fastest star. So we've discovered a star at the center of the Milky Way galaxy, which is traveling at 18 million miles per hour. That number, even though I'm an astronomer, that number doesn't quite go into my head. 18 million miles per hour. The reason it's going that fast is because it's orbiting a giant black hole at the center of the galaxy, which has incredibly strong gravity. And if you weren't going that fast, you'd have long ago fallen in. So only the stars that were going really fast have been able to survive around this monster black hole. So what is a black hole? A black hole is a place where stars have collapsed at the end of their lives. When they run out of fuel, the biggest stars just collapse under their weight so much that nothing can get out of them. They become so strong in gravity that nothing, not even light, can escape from them. And if light can't escape, what color will they be? They'll be black. And if light can't escape, nothing can escape. So if you throw a teddy bear in, you'll never see it again. We call that a hole. And so astronomers have called these collapsed stars black holes.
Well, excuse me, Andy, they're kind of eating or ingesting or ferociously taking in more than stars. They're taking in all kinds of things out there. I mean, just remarkable what they're taking in.
Right. A black hole is not particular because its gravity is pulling things in. It will pull in whatever is nearby: gas, dust, stars, planets, television sets, whatever you put next to them, the gravity will pull it in. And what this fast-moving star and other fast-moving stars in the same neighborhood have allowed us to measure, Michael, is how much mass this giant black hole at the center of the galaxy has already eaten. So are you ready for this? This black hole has eaten the equivalent of 4 million suns. 4 million suns worth of matter are already inside this black hole. By measuring the speed of this star, it can tell us what the gravity pull is, and therefore what the mass is of this giant black hole. So that was a fun discovery. Actually, 2 people in the UC system, UC University of California system, won the Nobel Prize just a couple of years ago for measuring the mass of this monster black hole by looking at these fast-moving stars. But now finally, to get to the sexiest part of your question. So one of the other great discoveries that we've made in astronomy is that a good part of the universe seems to be made up of matter whose gravity we can detect, but from which no light or other kind of radiation can be seen. And we call that dark matter because it's dark to our eyes and instruments. And it's not just light that we can't see from it. We can't see infrared. We can't see radio. We can't see any kind of radiation, even though we know from its pull as it pulls stars around that this dark matter is there.
And it's also analogous to what we see in politics is called dark money, right? We don't know where it comes from or where it's going.
Oh, my goodness. Yes, that's absolutely right. The analogy is right there, that are behind the scenes, unknown to you, matter that we can see is being manipulated by something dark. Absolutely correct. And it makes me always tell my students that they should ask for some of their money back for the course that they paid to take from me, because in this course we promised to explain what's in the universe, and here's this dark matter and we can't explain it. We literally have discovered it only a couple of decades ago. Experiments are underway to figure out what other forms of matter there could be that we haven't yet discovered. But right now, this dark matter is a completely unknown form of existence, an unknown form of material. We say material because it has gravity. And I can tell you there are PhD students all over the world hoping to get the Nobel Prize by discovering what this dark matter is, but there's been no hint so far.
Well, it remains an enigma, and yet it's probably, if we're talking about substances out there, it's there's more of that than there is of just about anything. We've got more questions coming in. This is from Germany. Stefan Fischer wants to know, getting back to extraterrestrial life and questions along those lines. An astronomer told that extraterrestrial intelligence with our current technology would not be able to detect our planet Earth from its position in space. If yet it would take too long to get here. So the Star Trek moment will never come?
Great point. So it's absolutely true that as proud as we are of our technology and our civilization, if you lived around a distant star and you looked at the Earth, there would be nothing about the Earth right now that would reveal our technological civilization. The strongest signal that the Earth makes, I'm sort of ashamed to say, the strongest signal we make is actually the planetary defense radar. We have radar beams pointing at Russia, to make sure that if they launch a missile our way, we had advance notice. Russia has a very powerful radar pointed at us for the same reason. Same with China. Those ICBM or intercontinental ballistic missile radars, those warning systems about our hostile intentions, that's the loudest signal on Earth. And it's still pretty weak. So from a distant star perspective, it would be very difficult to detect that. And nothing else we do, not the radio, not the television, not the lights at night, nothing is strong enough to signal that there's a technological civilization on Earth. On the other hand, we're still a very young civilization, given the millions and billions of years of cosmic time that passed before the sun and the Earth ever existed. We're a pretty young civilization. So it kind of makes sense that we haven't yet made a big splash in the cosmic scheme of things. But other civilizations may be sufficiently far in advance that they give off more powerful signals. And that's what the SETI project is trying to record. Something from a more advanced civilization that may be giving off louder or more easily detectable signals. And we can overhear them, or we can get the waste heat from their giant space colonies, or something about their technology might show itself to us.
And once again, you're listening to Gray Matter with interviews with Michael Krasny. Our guest is Andrew Fraknoi. That's gray with an E, and gray as opposed to dark matter. Let me go to some more of our listeners. Juan Robles joins us from Mexico City, and Juan wants to know, what are the technical limitations that astronomy is facing in the next decade? He wants to know about technical limitations. Thanks for that,
Technical limitations. Wow. Well, I jokingly, we always say that the biggest technical limitation is money. To build these giant telescopes, we need huge budgets. And it's really nice that governments, not just here in the United States, but around the world, are devoting a tiny fraction of their budget to building these amazing instruments for probing the universe. I think that's a hopeful sign for the existence of intelligent life on Earth, that we're not spending all these budgets just to fight each other, but we're actually spending a little bit of our budget to find out the secrets of the universe. But technologically, I think one of the biggest issues we have is telescopes in space. When we put telescopes in space, like the James Webb Space Telescope, it's hard to repair them. If something goes wrong with the James Webb Space Telescope, it's 1,000,000 miles from Earth. Right now, we have no vehicle or plans to be able to send an astronaut there to fix it. So that's why we're so glad that the James Webb worked so well as we unfurled it and as we got it to start its scientific work. But the technology of space exploration is still quite a challenge. We've sent spacecraft as far out as Pluto and beyond. The spacecraft called New Horizons has now gone beyond Pluto. But we're really still in the infancy of using space as a way of exploring the universe, of putting better and more sophisticated instruments into space. At the same time, we also want bigger telescopes on Earth, and there are plans to build giant mirrors in places around the world. We have to find the right locations, and we have to find the budget. The bigger the mirror, the fainter the things, the more distant the things that you can see.
Let me bring some more questions in. Hersha Trivedi from Central Florida. Thank you for this question. It's how may be astronomy expressed in more tactile format for those who may not be able to access the same information?
So this is actually something that NASA and others are thinking about right now. Thank you for asking that question. So what if you're sight impaired? What if, for example, you can't see the night sky? How can we give you a tactile feel for what we're discovering? There's a really wonderful woman named Noreen Grice, Grice, who has thought about this problem for decades and has created Braille astronomy picture books. And NASA is now getting into this too. So it is possible now for people who have issues with their sight to be able to feel some of the beautiful images. And there's a whole code developed that I don't know very much about for turning NASA pictures and NASA words into tactile information, into Braille books about astronomy.
I'm going to go some more of your questions in just forthwith here, but I wanted to cover something that I mentioned initially because it's probably a lot more interesting, and there's a lot more to learn from this than many of us may have perceived. I'm talking about the Perseverance rover and Ingenuity helicopter on Mars. I mean, there's always been this fascination going back to Edgar Rice Burroughs, and so you've been writing science fiction. We'll talk a little bit about that too. But with Mars, the red planet, because it's so close to us, and it has this identification with, well, a Greek god warrior and all those kinds of things, we always assume that there may be something up there. This is a pretty sophisticated mission. We're learning stuff about Mars that we really didn't know and didn't imagine, aren't we?
That's right. So the Perseverance rover is the most sophisticated science lab we've ever put on another world. And just for fun, we put a little drone helicopter at the bottom of it, which could detach itself. And we thought that's pretty crazy because the atmosphere on Mars is so thin that your first deep breath would be your last deep breath. It's thinner. It's about as thin as the Earth's atmosphere, 100,000 feet up. And so flying in so thin an atmosphere is an absolutely crazy idea. So they made this tiny drone with nothing in it except a camera and made of lightweight material with rotors that spin much faster than any Earth helicopter, just for the heck of it, to see if we could fly in the thin atmosphere of Mars. And by gum, they did it. It actually flew. The first powered independent flight on another world. And it flew so well that instead of a couple of trial flights just to see if they could do it, we've now done dozens of flights. The helicopter has flown for a total of 4 miles, and they're using it as a scout. The rover is actually trying to get to a pretty dangerous territory on Mars. They want to send it on a really smooth terrain. So they're using this Ingenuity helicopter as the scout to have it fly in advance and tell them from the air what the terrain is that the rover is going to encounter. So I'm just fascinated by this idea that we can fly a little helicopter on another world. But what the rover's doing is really the scientifically exciting part, which is we've discovered that ancient Mars was completely different from Mars today. I said that Mars today has very thin air. The air, in fact, is so thin that water could not stay liquid on the surface of Mars today. Water would either freeze or evaporate. You need air pressure to have liquid water. Yet ancient Mars, we now know, had a much thicker atmosphere, perhaps as much or more pressure as Earth, and water pooled easily on the Martian surface. So ancient Mars probably had lakes and rivers, and even perhaps tide pools, although there isn't a big moon to pull the tides, but the equivalent of little pools of water. So we wonder whether life might not have started on that ancient Martian surface in water, just like it did on Earth. And today that water is gone, but perhaps we can find fossilized evidence of ancient Mars. So we're trying to follow the water, and this rover is going into essentially a river delta, an ancient river delta, where a river brought water into a lake. And if we can get to that delta and take samples, this Perseverance rover has little tubes into which its robot arm will put samples from this ancient river delta. And another mission in a few years will come, land there, pick up those tubes full of samples, and bring them back to Earth. So the idea would be to try to see if there's any evidence of ancient life in the samples from that river delta.
Maybe we could also learn why they lost all the water. I mean, like we've often tried to figure out why the dinosaurs went here, right, and figure out why didn't Mars lose all that water, right?
Yeah, and we have a pretty good sense of that already because Mars is a smaller planet. So the water came from the gases that formed with the planet. It came from comets that delivered water. But because Mars was so small, its gravity was not able to hold on to its air. The Earth, because of its gravity, has held on to its air. Venus, which is another planet the size of Earth, has held on to even more air. But Mars was much smaller. It was sort of pathetic among the inner planets, and its gravity simply couldn't hold on to the air. So over billions of years, the air simply evaporated away, not held in check by the lower gravity of Mars.
Lots of questions. Here's one from Brody Hefner, who says, if you could influence NASA's future investment priorities, what opportunities would you emphasize? For example, should we be sending probes to examine Europa's water oceans? And by the way, there are those who feel maybe we should also be examining our own oceans, which because we know so little about, as you go deeper and deeper, our oceans, and there's a lot of life down there too, life that we don't understand. And so you've heard this argument, I'm sure. Let's do that rather than go out in outer space. That would serve us more and so forth. Again, I'm kind of branding a few questions or putting them together here. But Brody's question, I think, is important. Where do you see NASA going?
Absolutely. I'm answering your last question first. I think it's absolutely true that we need to explore our oceans, but I hope we don't have to make a choice. Why should we have to do one or the other? With the science budget that we have, I think we could do both. But
well, the argument would be that if we go to Europa, we're going way over in our solar system as opposed to being closer here to home where we can find out more that affects us. That's the argument, isn't it?
Right. But let's talk about Europa in a second. But if we're looking at other worlds, we might be looking at different forms of life. And we want to find out both about what's happening with our form of life at the bottom of the ocean and different forms of life. But you're absolutely right. The issue is, and has been for some time, NASA can only get so much money. What should we do? What should we do with that money? One of the things that we as astronomers often worry about is that the sending of human beings is a lot more expensive than the sending of robots. On the other hand, it's a lot sexier and is more likely to get funding from Congress. So we have this dilemma of, if you ask scientists, what should NASA do? We would say send robot probes and robot telescopes. But if you ask politically what's viable, well, people are very sexy. So if you send people to the International Space Station, if you send someone back to the moon, that's the kind of thing that will get even the most hardened Congress people to give you money.
Do they have to be sexy people?
No. I think the topic is sexy. I didn't mean to imply that the astronauts.
No, I was joking.
Yeah, but indeed, if you asked me, which is what the original question was, I would always opt for robots. And the next things I would do is exactly what we were talking about. There's a moon orbiting Jupiter called Europa, which is covered with ice, mostly water ice. And there's good evidence from the cracks and surface features in that ice that under the ice is a giant ocean. And the ice will probably be able to keep that ocean warm for many, many, many years, and has been doing that. So in that underground ocean on this moon Europa, could life have formed? Could that be a place where energy coming from inside the moon, it's a heated moon in the inside, could that energy and the chemicals in that ocean have contributed to some sort of origin of life? The only way to know is to go down through the crack in the surface ice and send some kind of bathysphere or submarine down into the ocean of Europa. What an incredible challenge and wonderful scientific experiment.
And I think Brody wants to know, would you put the revenue into that? Is it worth putting that revenue into?
Yes, and there's already a mission on the drawing board called Europa Clipper. The folks at the Jet Propulsion Laboratory are designing the next step in that exploration. So we would all love to do that. There's also a moon around Saturn now called Enceladus.
It's got water too, doesn't it?
Yes, which we've discovered has water inside because geysers of heated salt water are coming up through the cracks and are being seen in space. Imagine warm water, salty geysers from a moon of Saturn's. What a wonderful time we live in.
Well, here's John Snyder from Reno, and thanks for this question, John. He says, as an astronomer and science fiction author, what are some, this will give you an opportunity to talk about your new frontiers with science fiction writing, but he wants to know, what are some rules you wish other writers would follow? What mistakes should they avoid?
Oh my goodness, what a nice question. So yes, as you kindly mentioned, Michael, I've my one of my retirement careers is to write science fiction, and I was telling Michael before the show that I have rejection slips from all the best science fiction magazines around the world. But now five of my stories have actually been published. And if I can make a slight plug, I have a website called fraknoi.com, Fraknoi.com. For some reason, that domain was not hard to get. And on that Fraknoi.com website, I've put my science fiction stories up there if you want to read it. My ambition is to write science fiction based on good astronomy, to take some of these ideas that I love talking and writing about and make stories out of them. And so the question is exactly appropriate. What I worry about is all the science fiction with unicorns and dwarves and all these fantasy features and magic. In a sense, we don't need magic. The real world is magical enough. And so I'd love to see more science fiction, which is based on the actual scientific principles we know and the scientific discoveries we've made. And there are lots of good people writing that kind of science fiction.
There's also, you think about Jules Verne and Isaac Asimov, there are science fiction writers who have led us to discoveries and have. I'm also, by the way, to this day, I must tell you, I've not read an enormous amount of science fiction. There's probably, for literary guys like me, a little snobbery about science fiction. Yeah. No offense. But probably the best science fiction novel I read was The Left Hand of Darkness by Ursula Le Guin, and remains up there in the pantheon, doesn't it?
Yes. Ursula Le Guin was the daughter of a famous anthropologist, and she writes wonderfully anthropological science fiction. And in The Left Hand of Darkness, she examines the whole question of what it is to be male and female, and what if those two roles weren't so clearly defined? What if the same creature could be male sometimes and female another time? How would that change the way you perceive the world? It's a wonderful story. I recommend that all the time. And there are anthropologically based science fiction stories. There are stories which look at the sociology of alien creatures in interesting ways. So it doesn't just have to be hard science that influences science fiction. I like to write about things like I wrote a story about a cave on Mars where we discover evidence of an ancient civilization, not one that was born on Mars, but that came to visit. And so there actually turn out to be caves on Mars among the volcanoes of Mars where future Earth civilizations might even find a place to live. So taking those kinds of ideas and extrapolating them has been really a lot of fun.
Well, look at Le Guin being so ahead of her time, with that fluidity of gender. We're in that epoch now, to be sure. And she wrote a wonderful dystopian story that I'd also recommend. You can probably find the PDF online. It's Those Who Walk Away from Omelas. Omelas was a Salem, Oregon, Salem O, backward in her rearview mirror. And that was how she got the title. Some more questions. Eric Antonio from Washington, D.C. says, thermodynamic entropy seems to be in direct conflict with gravity. Do these two effects deserve to be reconciled, or are they simply governors of completely unrelated processes? Thank you. And thank you for that question.
The gray matter listeners are very impressive. It's clear. So thermodynamics is the study of heat and energy. And one of the rules of thermodynamics that really shocked scientists and has guided them ever since, discovered in the 19th century, is that energy in any closed system tends to get more chaotic and disordered. I see that as an absolutely good reflection of my closet. The longer time goes on, the more chaotic my closet gets, and that the world in general gets more disorganized. And yet gravity and life organize things. You can think of yourself as the opposite of disorganization. Look what marvelous complexity and organization go into being you, go into the chemical changes, the biological changes, the mental changes that make you up. So we defy this rule of thermodynamics that says everything gets more chaotic and disordered. On the other hand, if you look at the world and global warming, you see a lot of examples of the world getting more disordered, more disorganized, of random heat going in different places. So this is a little bit untechnical, the way I'm explaining it, but you're absolutely right that life in the universe contradicts this tendency, which we call entropy. And the universe as a whole still has to obey the fact that things are getting more chaotic. Luckily, we have stars. Stars are a way that the universe organizes energy and produces energy and provides energy for a time, for a brief time, cosmically speaking. And every star, in that sense, defies entropy. It makes organized, fresh energy. Eventually stars die and things get chaotic again, but stars are wonderful entropy defiers. And because we live around the star, we have fresh energy from the sun to help us continue to defy the second law of thermodynamics.
Well, it's also makes me think analogously again of all these neurons that are dying as we get older, but new neurons are being born nonetheless. Yeah. So, I mean, entropic processes are hard to avoid. They're part of our longevity here on Earth, and they're part of really our planet's longevity and our universes, or all the other universes that may be out there. Question from, again, one of our team, Colin, is in Menlo Park, and he says, as an astronomer, are you excited or concerned about space-based solar power collection, especially Dyson spheres or less ambitious derivatives of such concepts? What are the downsides of blocking starlight in our solar system or elsewhere? And thank you, Colin.
Great,
like you say, we have some pretty sophisticated, smart people listening to us and on our team.
So Freeman Dyson, the great physicist, proposed some years ago that if you want to capture the energy of the sun, you really need a world bigger than the Earth. One of the problems with solar energy is that the sun wastes a lot of its energy by not shining it at us, right? Wouldn't it be great if the sun only shone at the Earth, wherever the Earth was, and didn't waste any of its energy shining out into deep space? Of course, that's nonsense, but it's an interesting idea. If we want to capture the sun's energy more, maybe we need to have a bigger collector than just the Earth. What if we put a lot of solar panels out into space? What if we took a bunch of asteroids and broke them up and made them into solar collectors? The bigger the surface that collected solar energy, the more solar energy we could collect and perhaps bring back down to Earth. So that's a Dyson ring or a Dyson sphere. Dyson imagined that in some really far future, a civilization would surround its entire star with solar energy collectors and then be able to absorb all the energy of the star. That's called a Dyson sphere. Some science fiction writers have imagined such a future civilization where a ring or a sphere of solar collectors has surrounded a star and we can't see the star anymore. As our questioner points out, the more of these solar collectors you put into space, the more you block the light of the stars. So that would be terrible for astronomy to surround the Earth with solar collectors. We couldn't see any of the stars or galaxies out there. And luckily, this is not something which is going to happen in the near future. But it's an interesting thing to think about. How much are you willing to give up for the ability to use more of your star's energy?
Dyson remains one of our most brilliant physicists, really, doesn't he?
Yes.
I mean, as a visionary, too. Really.
Yes, and he's written about many other topics as a visionary besides this one, but this is the one that science fiction writers know him best for.
So before I let you go, sort of bringing in the search for extraterrestrial intelligence and science fiction maybe together, I wanted to ask you about this Avi Loeb with the Hawaiian name of the trash coming from. This is the chair of the astronomy department at Harvard, who seems at least pretty convinced that it wasn't a comet that came to us. It was something that was from another civilization. Your thoughts?
Right. Well, so the thing we know and all agree on is that from its orbit, there was a chunk of material, part rock, part ice, which seemed to come from another star system, skimmed into our solar system, and went back out. We all agree that it was an interstellar visitor, a visiting chunk of material from another star. Most astronomers think it was a perfectly natural chunk of rock and ice. We called it Oumuamua, which is a Hawaiian term for visitor, and that's all good. Now, Avi Loeb and a few astronomers have suggested that the way this chunk changed its motion while it was in our neighborhood could not have been done by natural processes. It had to be done artificially by someone driving it, by some sort of engine inside, and that it could have been a ship or something from another civilization. Most astronomers disagree with that. They think that the melting or evaporation of the ice could have produced puffs of gas that changed the orbit of Oumuamua in a perfectly natural way. But Avi has written a very challenging book in which he says, no, it's an interstellar spaceship and we should pay attention. Most astronomers don't think that's so, but we appreciate the fact that it's an intriguing object. Now we've discovered a second object from beyond our solar system. So maybe we'll see more such visitors. And wouldn't it be great if one of them actually did turn out to be a spaceship and we could chat with the inhabitants? That would be the most exciting way of doing astronomy that I can imagine.
Time maybe for one more question. There are a lot of questions. We're going to have you back here on Gray Matter with us. And by the way, there are other Gray Matters, but this is the one with Michael Krasny, and we're talking to Andrew Fraknoi. And Kenneth from Seattle, Kenneth Jones wants to know, what is meant by the event horizon?
The event horizon is the zone around the black hole where if you're inside it, you can never get out again. So we call it the event horizon because events inside will never again influence events outside. Imagine if you fall into a black hole and you try to send a beam of light out. Well, it'll be pulled back in. You try to drive a spaceship out, you'll be pulled back in. Nothing you do inside the event horizon will ever again communicate with or influence the rest of the universe. So that's not a good place to go if you have loved ones in the real universe.
Andrew, always delightful to talk to you. I know our listeners enjoyed it immensely, and this is our 6th episode of Gray Matter. Simply, if you want to learn more or access us about previous episodes or join us, it's graymatter.show, and ongoing stellar work for you. Thank you so much for being with us.
Great to be with you. Thank you, Michael.
Bandwidth for Gray Matter is provided by CacheFly at CacheFly.com.